All right, today we continue our journey through Chapter 5, currently on Section 5.4, Factor and Solve Polynomial Equations. Very important when you're factoring and solving polynomial equations that you understand all of the little intricacies that go into that. And that's what this section will be about. It'll all be about little tricks and things that are going to help you along the way. So I'll try to go through that with you. A little smokestack for you. Sitting my little home on the range there. Prime polynomials are just like prime numbers. Basically, they're non-factorable. That's what they're the only factors they have are them and themselves and 1. So numbers like 5 are prime factors. Will have things that are non-factorable, things that you can't factor. To factor something completely just means, finish the job. Take a look at everything. Even though you factored it once, you might be able to factor it again. So I'm just going to put the word finish right here. All right. To factor by grouping, I'm going to show you that with real numbers. It's kind of quirky. The one thing you'll have to know when you're going to factor by grouping, I want you to look for 4 parts. When you see 4 parts, I want you to think factor by grouping. And in quadratic form is an expression of the form ax squared plus bx plus c. And it's kind of what we already have. It's what we have already been doing. So ax squared plus bx plus c would be like a quadratic, which we've been using all along. Let's take a look at factoring polynomials and all that entails. Definition of a polynomial with 2 or more terms is a prime polynomial if it cannot be written as a product of polynomials of lesser degree using only integer coefficients and constants if and only if common factors of its term are -1 and 1. Remember, if you can only take out 1 and -1 from something, then it's a prime factor. 16x squared minus 4x plus 8 is not prime, because you can look at it right away and see that you can take a 4 out of all of those things, right? 4 is a common factor in there, so that it's not a prime factor. A polynomial is factored completely if it is written as a monomial or a product of a monomial and 1 or more prime polynomials. So like if I take it to simplest forms, when I talk about numbers, like a number like 24, that's not prime because 6 times 4 can be multiplied. But that's not been factored completely because I still have to do 2 times 3 and 2 times 2. And that's the same thing we're going to do, but with much, much bigger numbers. Take a look at this thing here. X plus 2 times the quantity x squared minus 5x plus 6. Maybe you got that, but that's not done completely because you can still factor the second piece there. And some of you are already looking at that going, oh, numbers that multiply to be 6. Let me think. And numbers that multiply to be 6, but then they add up to be -5. Well, must be an x minus and an x minus here. And numbers that add up to be 5 but multiply to 6 is 3 and 2. So you factor that completely. Let's change our color here. Let's go with green. And let's take a look at special factoring patterns. When we look at special factoring patterns, these are pretty tough. These are things that we need to think about a little bit. The sum of 2 cubes, and it's kind of just memorizing this whole format. And I'm not a guy for memorization, but it is memorizing this whole format. The format for the sum and the difference of 2 cubes is exactly the same except notice it's plus, minus, plus, and this one's minus, plus, plus. That's the part that you have to really think about. So what I'm looking at this here, x cubed plus 8 is really x cubed plus 2 cubed. Right? So if I have x cubed plus 2 cubed, then my x is my a term, and my 2 is my b term. So I have x plus 2, x squared, minus a times b, x and 2 are my two terms, 2x plus, and I square that last term, I get a 4. If I do a difference of 2 cubes, very, very similar. In this situation, 8x cubed, I really have 2x, that's supposed to be a 2, 2x cubed minus 1 cubed. And so 2x being my a term and 1 being my b term. So if I square my a term, I get 2x quantity squared. Make sure you do the whole quantity. So that's going to end up being 4x squared. Plus, it says a plus in it. This one's minus plus plus. Has a plus in it. Plus, I multiply the two numbers together, 2x and 1, and I get 2x. And then I square my b term, which is just going to be 1. And I know you're saying, look at Mr. Emeott, that 1 is a negative 1. Yeah, it is. That's what changes the plus and the minus signs around here. So that's how you're going to do that. So when it asks you to factor this completely, it ends up being z cubed minus 5 cubed. And then I just follow that pattern right there. Z minus 5, z squared. And it's a minus plus plus. So plus 5z plus z squared. I think my z is backwards there, isn't it? That's what's the problem. I'm trying to make my z's look like 5. That should be z minus 5 times z squared plus 5z plus z squared. Terrible, terrible handwriting, I know, but I hope you're listening and writing so you can get both of those things. On this one, on B, the first thing you have to do is notice that 3 goes into both of them. So after I take my 3 out of both of them, I have 9y to the 4th. Actually, 3y goes into both of them. So I have 9y to the 3rd plus, and when I take a 3 out of that 192, that's 64. Wow, that's not easy for anybody, but if you think about what that is, 9y to the 3rd and 64, what exactly do I have there? Well, some of us might see that I have factored it pretty well and done a pretty good job there. And the 3y, when I took my z out of there, oh, this should not have been 9. This should have been 27. That's not good. So we're going to do it over here. I knew there was a problem there as soon as I looked at it. It should be 3y times 27. Yeah, 81 divided by 3 is 27. Y cubed plus 64. Now that's going to be a little better. Now I have a sum of 2 cubes. Now, you might not see them right away, but what they are is 3y quantity cubed. And what number cubed is 64? Anybody know? Anybody know? Nobody? Nobody? 4. I might have heard one person screaming at the computer. 4 cubed. So there's my a and there's my b, and then I follow that same process that I followed earlier. You know, the a, it's a plus, it's a sum of cubes right here. So I look at my sum of cubes and I do a plus b. So in this case, it's going to be 3y plus 4. And then I square the a, 9y squared. See, that's 3 squared is 9. I multiply them together, remember, if it's a sum, you can have a minus right there. Multiply them together, and I get 12y right here. And then I square the 4 plus 16. And that's how I'd finish that. You go ahead and take a moment, pause it, and take a look at checkpoint number 1. All right. Welcome back. In checkpoint 1, you first have to figure out what the cubes are. Now, if you see that cube, that should be a hint to you right away. Oh, this must be that sum of cubes thing that he was talking about. So on my calculator, I'm going to cube root 8 and find out that it's 2. So I have 2x cubed. And I'm going to cube root 64, and I'm going to find out that that's 4. And so my a is 2x and my b is 4. Now I usually write them like this so then I can just keep working. So when it's plus, take a look at your pattern, go back up to your pattern. When it's plus right here, then it's plus, minus, minus. So let's come back down here and see if Mr. Emeott can make all this match back up. No, not really, all right? Let's move that screen up just a little bit. Move that screen up just a little bit more. There we go. 2x, so it's plus right here. And then it's 4x squared. I squared the 2x. Minus, multiply them together, 8x. Square the final one, 16. Hopefully that's what you guys got for an answer. And it's just following those basic steps. Now, factoring by grouping is a little different. And some of you guys are going to see this right away and some of you are not. Again, I'm going to say to you, it's 4 parts. If you see something in 4 parts, you got to think factor by grouping. Probably the most challenging concept we're going to talk about right now. There are 2 groups here. There is this group right here, and then there's the rest of it. Anything go into the first 2? Well, x squared goes in the first 2, and I'm left with x minus 2. Anything go into these? Oh, 9. Well, actually, negative 9 goes into both of them, and I'm left with x minus 2. If you divide a negative 9 out of here, it's 1. Negative 9 out of here, it's negative 2. Well, what they want you to see from here is that you have x squared times x minus 2 minus 9 times x minus 2. So that's x squared minus 9, that whole quantity, times x minus 2. That's tough, tough stuff. And then you got to finish it, because x squared minus 9 is a difference of 2 squares, x minus 3, x plus 3, x minus 2 is the answer. That is a really, really tough problem. And if you're able to do that, I would be impressed. It takes lots of practice, tons and tons of practice, doing 10, 20 of those types of problems to be successful at that. All right. Example number 3 is in quadratic form. And quadratic form simply means it looks just like it used to look, but you have to notice that it's to higher powers. And so if this is a difference of 2 squares, it's 4x squared minus 16 squared, and 16 is a perfect square also. So it's still a difference of squares, so you'll line it up. 4x squared minus 16, 4x squared plus 16. But this is where they're talking about it's got to be factored completely. Now I still have a difference of squared. Here, 2x minus 4, 2x plus 4 times 4x squared plus 16. And that's factored completely. So on that one, you work it just like you would normally work it, but you got to notice that it's in that form. Just like this one here is y to the 3rd, y to the 5th, y to the 7th, and they're all divisible by 3. So I'm going to take 3y to the 3rd out of all of them, and I'm going to be left with y to the 4th minus 5 y squared plus 6y. Or plus 6, sorry. And then you can break that thing down. So let me change my color again real quick so you can kind of see the difference what I'm doing here. I have y squared, or y to the fourth minus 5y squared plus 6. Well, I can break that down to be y squared and y squared. And numbers that multiply to be 6, but add to be 5, just like we did a few moments ago, 2 and 3. But they both better be negative. So I have that, and I also have the 3y cubed out front. Okay? So that ends up being the answer here. Go ahead and take a look at the checkpoint and see how you do, and pause it for a minute and work them out and see if you can see what I see. All right, welcome back. Let's see. Did you see that this was grouped? Did you see that it was x squared times x plus 2? See, it was how many parts? 1, 2, 3, 4. So it's got to be grouped. And I want to make the other one look like x plus 2. So I'm going to take 25 out of both, negative 25. And I have x plus 2. Lots and lots of practice. Now I can use the distributive property. So I have x squared minus 25, parentheses, times x plus 2. And it's not factored completely because this is a difference of squares. X minus 5, x plus 5, and x plus 2. What they're doing here is it's no different than if they were to say 7x minus 4x is the same as 7 minus 4 times x. It's that same concept that they're trying to show you. Over here, 2 parentheses, x squared, numbers that when multiplied equal 45 but add up to 14, sounded like 9 and 5 to me. But the 9's negative, the 5's positive. Am I done? Is it factored completely? Nope. This is a difference of squares. X minus 3, x plus 3. Pretty tough stuff. So that all reduced to this, and you had these 3 parts. Pretty tough. Let's take a look at solving polynomials, because let's face it, that's what it's all about. It's all about, can I solve equations or can I not solve equations? So on this one, I'm going to subtract 10x squared. I'm going to get x to the 4th minus 10x squared plus 9. Numbers that multiply to be 9 and add to 10. That's right. Somebody said x squared minus 9, x squared minus 1. Okay? They can break up just like that. Now, I have a difference of squares. X minus 3, x plus 3. Difference of squares. X minus 1, x plus 1. And what do we have for an answer? Well, this one is going to be 3. This one, negative 3. This one right here, 1. This one right here, negative 1. I end up having all of those as my zeros. Now, you know what that means? If I were to graph that on my calculator, what you would find is a graph that passes through 1, passes through 3, passes through negative 1, passes through negative 3. It would also be positive, which means, remember in section 2, it's going to end down there and up here. It's even. So because it is even, it's not going to end down here. It's going to end up here. I should have known that first. But it does mean it makes like a smiley face. It opens up. And it's going to go through the negative 3 and through the negative 1 and through the 1 and back through the 3. graph that on your calculator, see if I'm right. Let's take a look at checkpoint number 4. Take a moment and see how you do. All right, welcome back. Hopefully you subtracted 14x cubed right away, and you had 2x to the 5th minus 14x cubed plus 24x equals 0. Remember, 0, that equaling 0 is going to be important every time you do it. What goes into all three of these things? Well, it looks like 2x goes into everything. So I'm going to rewrite this up here. 2x goes into all of it. So I'm left with x to the 4th minus 7x plus 12. Numbers that when I multiply them together get 12, add up to 7. You can use your snip method or graph it or whatever you want to do. 4 and 3 is what you end up with. X squared, and they're both going to be negative because when I multiplied them I got 12, but when I added them I got negative, or when I added them I got negative 7. All right, so this isn't done. I end up with an x minus 2 and an x plus 2. All right, and I have a 2x over here, and I have an x squared minus 3 right here. What are the real solutions? Well, this one right here is 0. This one is 2. This one, negative 2. Oh, I'm 3/4 of the way there. I'm so happy. Uh-oh. What's this one? X squared minus 3 equals 0. That's how I solve this. X squared minus 3 equals 0. Add 3 to each side. I get x squared equals 3. And so I get positive, negative, square root of 3. And that gives me 5 answers. 1, 2, 3, 4, and 5. And I should have 5 answers because it's a 5th degree polynomial. All right, thank you very much, folks. We'll make sure you put question marks by all the things you didn't understand so we can talk about it tomorrow. Thank you. Have a good day.